Currently in the year 2017, the world's population stands at 7.5 billion people. However, as we approach the year 2050, our population will grow to nearly 10 billion people. As a result of this growth in population, our energy needs will grow as well. And so this poses the question of which energy source will best meet the needs of the future generations. Well, the International Renewable Energy Agency has a couple criteria to figure this out. First, ecological footprint, or the impact of the creation of energy on the environment. Secondly, fuel supply, or the availability of fuel sources to sustain energy production. Thirdly, energy efficiency, or the ability to create the maximum amount of energy using the fuel provided. And lastly, the cost to sustain energy production. The first energy source that we're going to be reviewing is wind power, or the energy that is harnessed using wind turbines. Now let's run this energy source against the criteria we spoke about earlier. First, ecological footprint. Obviously, wind power is a renewable energy and thus has a small ecological footprint. However, some people living close to wind facilities have complained about sound and vibration issues stemming from the wind rotors, and as a result, I gave it a 7 out of 10 score. In terms of fuel supply, it is a renewable energy source and wind isn't really going anywhere, so I gave it a 10 out of 10 because it is unlimited fuel supply. Thirdly, energy efficiency. Onshore and offshore windmills have an energy efficiency of 95 to 98%, which is completely outstanding compared to any other energy source, and for that reason I gave it a 10 out of 10 as well. In terms of cost, it's relatively inexpensive, but more expensive than other renewable energy sources, and for that reason I gave it an 8 out of 10 as a score. The second energy source that we're going to be analyzing today is nuclear energy, or the energy that is harnessed by splitting atoms. Now, we have our 4 criteria, first being ecological footprint. Now, the ecological footprint of nuclear energy is actually relatively small. It scored a 3 on the emissions intensity, which is pretty much the kilograms of CO2 that is produced per megawatt hour. Now, this is a lot lower than any fossil fuel or renewable energy, and for that reason, I gave it a 10 out of 10. Now, in regards to the fuel supply of nuclear energy, it can be sustained for the next 100 years. However, more efficient fast reactors could extend that period to more than 2,500 years, meaning that if we continue to develop nuclear energy, we could get 2,500 years of a fuel supply, and for that reason, I gave it an 8 out of 10 for its potential. In terms of energy efficiency, nuclear energy actually scores pretty low because it can only have an energy efficiency of 33%, which is actually a lot smaller than most renewable energies and kind of competes with fossil fuels. And for that reason, I gave it a 6. In terms of cost, it's also relatively low, and for that reason, I gave it an 8. The third energy source that we will be reviewing is fossil fuels, which pretty much entails 3 things: natural gas, oil, and coal. Now we have our 4 criteria, first being ecological footprint. Obviously, fossil fuels don't really do well with this criteria, largely because their kilograms of carbon emissions per megawatt hour are from 440 to 750, which is much more than any renewable energy source, which kind of made me choose a 4 out of 10 as its score. In terms of its fuel supply, its proven reserves are around 100 years, which is kind of small compared to, let's say, nuclear reactors or renewable energies, and for that reason I gave it a 7. In terms of cost, that's really the only place it wins, which is relatively cheap even compared to renewable energies, and for that reason I gave it an 8 out of 10. In terms of energy efficiency, fossil fuels have a global average efficiency of 36%, which competes with nuclear energy at 33%, but does not compete with, let's say, wind power, and for that reason I gave it a 6. The final energy source that we will be reviewing today is solar power, or energy that is harnessed through the sun's rays. Now we have our 4 criteria, first being ecological footprint. Now obviously, because solar power is a renewable energy, it does have a low ecological footprint. As you can see, the kilograms of CO2 produced per megawatt hour is 100. Now this is relatively high for renewable energies, but compared to fossil fuels, it's still very low, and for that reason I gave it an 8 out of 10. In terms of its fuel supply, it is renewable, and so it does get a 10 out of 10. In terms of cost, it is relatively high compared to any other fuel source, and for that reason, I gave it a 7. In terms of energy efficiency, though, the solar power kind of fails in regards to other renewable energy sources, and this is because solar energy takes 2 years to pay back the energy used for their production, which means that it takes 2 years to produce the same amount of energy that was used to produce a solar panel. And for that reason, I gave it a 7. Now that we've scored each individual energy source against the 4 criteria, we can start to answer the question of which energy source will meet the needs of future generations on Earth. If we take the total score by adding up each individual criteria score, we get 32 for solar energy, 32 for nuclear, 25 for fossil fuels, and 35 for wind energy. Hence, it's evident that wind energy is the best possible energy source for the future because it has a low ecological footprint only due to its noise pollution, a very good fuel supply due to its renewable status, an energy efficiency close to 100%, and a low production cost. As a result, I highly recommend current generations pursue the development of wind energy for the betterment of man and planet Earth.